Hello class. So today we're going to learn about interpreting coefficients and also checking their significance using a dataset. So we are using the dataset wage2.dta, which is from Wooldridge's textbook. So I downloaded that and now I'm going to write on my do file the codes and then also the interpretation of the codes. Now supposing we just first want to run the wage regression. So let's say we will run just wage as is, and we want to see how education, IQ, and tenure, and maybe also married variable, how that affects the outcome. Now, we want to check, let's say, before we started our analysis, we first came up with a regression model. Let's say we did that. And we are testing our model using this data. Now, to test the model, we first need to come up with some here. Let's say we want to test whether education has an effect on earnings. So if we want to test if education does or does not affect on our earnings, we first have to come up with our null and alternate hypothesis. So here we are saying, let's say education does not affect earnings. So the null is always that there is no effect. So the effect of one variable on the other is effectively 0. The alternate is education does affect earnings. So education has a significant impact on earnings. Now let's say we are running our regression. This is our regression for the model, and we run that and see wages and levels, and we find our education is, the coefficient on education is 45. Now the t-value is 7.09. So in order to test whether this variable is significantly affecting wage, so we first have to check, let's see the number of observations, which is 935. So that's a big enough observation. So we can write the coefficient is 45.64, and the t-value is 7.09. Now we need to compare this t-value, 7.09, with the critical value of t, which we obtained from the t-tables. So the t-table will tell us, like, at what values, or at what range of values, do we think that education has a significant impact on wages, and in what range of values is the effect as good as 0. So as we said in class, for 95% significant level, or if we want the critical value to be at 5%, the t-statistic, the critical value of t at 5% level is 1.96. So it's plus minus 1.96. So if our critical value of t is within that range, so it's between 1.96 to negative 1.96, then we say that the coefficient does not have an effect on, or the variable does not have an effect on wage. But if it's greater than the absolute value of 1.96, then we say that the variable has an effect on wages. So here we see that, okay, so we're comparing this 7.09, the t-value that we found here, with the critical value of 1.96. So the t-value is greater in magnitude than the critical value of t, which is 1.96. I'll put that in parentheses. So therefore, we can say that this coefficient, 45.64, is significantly different from 0. So now when we are interpreting the coefficient, we will say that a 1 unit increase in education will increase wages by $45.64, and the effect is significant at the 5% level. Now let's say we want to look at the natural log of wages. So let's generate ln of wage. So we can write gen ln wage equals ln of wage. And so we will run the same regression, but instead of wage, we will run ln of wage. So we did not generate it first, so let's generate that. And now let's run ln of wage as the dependent variable, and we find this. So now our dependent variable is in natural logs, so now we have to express the variables in percents, or we have to explain the coefficient in percent. So we again look at it, the coefficient is 0.0438 for education, and the t-value is 6.60, which is definitely much larger than 1.96. So now if I wanted to interpret the coefficient, I would say that 1 unit increase in education will increase earnings by 4.38%. This will be converted to percent. So it's not 0.0438 points. We have to now say it in percents because wage is in natural logs. And if you do the derivative, you will notice that this turns into a percent. And now we have to say this is our magnitude, this is the impact. Now we have to mention whether it is significant or not, and we will say and the effect is significant at the 5% level. Okay. Now let's look at a log level or a level log regression. So let's say instead we are looking at, instead of looking at IQs, let's create a natural log of IQs. So we can say gen ln IQ equals to ln of IQ. And let's run our regression. Wage. Let's say we're running it as the dependent variable is in levels and our ln of IQ is in logs. Okay, it's not gen, it's reg. And now once you do that, if you look at it, ln of IQ is 440, and the t-value is 4.96. So let's write down here the coefficient is 440.89, and the t-value is 4.96. Now, if I want to interpret it again, I look at the t-value first to see if it's significant or not. Well, it is significant. It is greater than 1.96 in absolute value. So I would now have to report it as, or I would have to just write it out first and report it as in plain English in sentences. So now if you notice that ln of IQ is a natural log, so if you remember how we did our regression, after regressions, or after, like, if it's in natural logs, the way we took the derivative to find out the effect. So now my IQ is in percents. So the interpretation would be, instead of a 1 unit increase in IQ, it would be a 1% increase in IQ would increase my wages by, now here it is 440, but if you remember, we have to divide that by 100 to, and that went into the analysis, so it would be 4.41 dollars. So if you look at it, this IQ, since if I excuse me, if IQ was in levels instead of in natural logs, we would just say a 1 unit increase in IQ would increase wages by that many dollars. But here IQ is in natural logs, so instead of 1 unit increase, I would say a 1% increase in IQ. And the coefficient was 440, we need to divide it by 100, and the process we went through it in class, it's also in the notes, so you could take a look in that, why we are dividing it by 100. And the units of wage is still in dollars, so we would just say it's $4.41. Now if we look at a log-log regression, let's say, so where we are doing all this, and let's say we are doing ln wage, so in this case, if I look at ln IQ, both of them are in natural logs, so the coefficient, let's first write what the coefficient is. Coefficient is 0.50, and the t-value is 5.48. So it's greater than 1.96 in absolute value, so I would now say, since both of them are natural logs, let's say ln of wage and ln of IQ are both in natural logs, so I would say a 1% increase in IQ would increase wages by 0.5%. And this effect is significant at the 5%. We actually did not write this in the here, so we actually should write it. Okay. Now another thing is, let's say we added more regression. Let's say we add, let's say, tenure, siblings, birth order, whether they live in urban, whether they live, whether we have mother's education and father's education. So let's take these two, mother's education and father's education, and let us add that here. Now, we can just say these are additional regression. Now, supposing I run this regression. Now here, supposing I can interpret education's effect, or 1 unit increase in education. Let me write it down here. 1 unit increase in education would increase earnings by 3.53%, and it is significant at the 5% level. So we can say the same thing with ln of IQ. Now let's look at mother's education. If you look at mother's education, well, the coefficient is 0.08, but the t-value is 1.39. For mother's education, we find that the t-value is less than 1.96 in magnitude. So since it's less than 1.96, so therefore we will say that mother's education, the coefficient is no different from 0. Or in other words, we will say, well, mother's education has no effect on wages. Similarly, we will say father's education has no effect on wages. We don't have to go through and interpret the effect of 1 unit increase in mother's education on ln of wages because the t-values are less than 1.96 in absolute values, so we can go ahead and say they're as good as 0. Okay, hope this helped.